Let's start with listing out group 1 elements. Group 1 elements बताओ.
Lithium, sodium, potassium.
Lithium, sodium, potassium,
रुबिडियम और सीजियम.
रुबिडियम और सीजियम. इनके कॉन्फ़िगरेशन भी बता दो. लिथियम
सर लिथियम का हीलियम 2s1.
वेरी गुड. इज हीलियम 2s1. सोडियम का
नियॉन 3s1.
नियॉन 3s1. पोटेशियम इज
आर्गन 4s1.
वेरी गुड. नेक्स्ट
क्रिप्टॉन 5s1.
ओके, वेरी गुड. नेक्स्ट
xenon 6s1.
xenon 6s1. ओके ओके. Down the group. If I go down the group, what happens to ionization energy?
It decreases.
Ionization energy decreases as number of shells increase. Or else I can say as atomic radius increase. As number of shells or atomic radius is increasing, ionization energy is decreasing. If ionization energy is decreasing down the group, what can I comment on metallic nature?
Increases.
Okay, metallic nature increases. Okay, down the group, if ionization energy decreases, what can I comment on reactivity?
Increases.
Very good. Reactivity also increases. And ये reactivity को डिस्कस करने के लिए हमने ऐसा कुछ बात किया है. लिथियम जो है, it can react. Lithium reacts only with steam. And even then, the reaction is slow. Only with steam, and I'm adding one more point, slowly. Okay. लिथियम के बाद सोडियम जो है reacts
Vigorously.
Very good. Sodium reacts vigorously. Okay. Potassium
Vigorously
with fire.
reacts vigorously.
May catch fire.
Or like I'm saying, reacts violently and catches fire. Okay. What can you comment on rubidium?
Rubidium explosive बोला था.
And both explosive.
Both of them react explosively. Explosively, and they can react even with cold water. Agreed? Okay. Next, tell me the reaction of lithium with water. With water, right? With air. Reaction of lithium with air. It will lead to the formation of
Li2O.
only oxide, which is Li2O, lithium oxide. If sodium reacts with O2, Na plus O2.
Oxide or peroxide.
Very good.
अगर एक्सेस में होगा तो peroxide होगा.
Very good. पहले oxide बनेगा. If we are having excess amount of O2, it eventually converts into peroxide Na2O2. Okay. If you are having potassium, rubidium or cesium, ये सब with oxygen, first they will convert into
Oxide. Peroxide फिर superoxide.
Very good. Rb2O, CS2O, which on further reaction with O2, they converts into peroxide K2O2, Rb2O2, CS2O2. Peroxide में what is the oxidation state of oxygen?
-1.
-1. फर्दर O2 के साथ रिएक्ट करने से it converts into sulfur oxide whose formula is KO2,
KO2.
RbO2, CSO2. And what is the oxygen state of oxygen in case of sulfur oxide?
-1.
-1.
Okay, -1/2. Okay, oxygen का O2 -1 और else इंडिविजुअल ऑक्सीजन के लिए वो -1/2 हो गया. ओके, इसके बाद आपको और एक इम्पोर्टेंट क्वेश्चन दिया था विच इज ये जो Li2O है रिएक्शन विथ वाटर एंड पेरोक्साइड Na2O2 reaction with water and superoxide KO2 reaction with water. Can you tell me the products?
हाँ सर, पहला LiOH.
Lithium oxide, any metallic oxide is considered as basic in nature, so whenever it is dissolved in water it will lead to the formation of base, so आपको LiOH मिलेगा. Okay, good.
सर दूसरे में NaOH plus H2O2.
Very good. In the second case, you will be getting two products. One is the base and the other is H2O2. Third case?
Sir, KOH, H2O2 or O2.
Very good. You will be getting three products, KOH plus H2O2 plus O2. You will get three products. Okay. Down the group, what will happen to the basic nature of the oxides?
Basicity will increase.
Basicity will
increase.
Increase matlab I can say Li2O is less basic when compared to Na2O, lesser than K2O, lesser than Rb2O, lesser than CS2O. Agreed? Or down the group, basic strength increases. If this is the basic strength of oxides, what can you comment on basic strength of hydroxides? Again, same. LiOH will be less basic than NaOH, lesser than KOH, lesser than RbOH, lesser than CSOH. Okay, good. इनके अलावा we have discussed about flame test. Flame test में what is the color of lithium, what is the color of sodium, what is the color of potassium, then what is the color of rubidium, and what is the color of cesium?
Sir, lithium का red, crimson red.
Lithium is something called crimson red. Okay, I hope this particular red is crimson red. Okay, sodium is
golden yellow.
Golden yellow. Is this golden yellow?
Yes.
Okay. Let us hope this is golden yellow. Potassium is
Violet.
Red purple.
Pale violet.
Pale violet. Pale violet. I'm taking this as pale violet.
So this is blue.
This is blue.
वहाँ पे था pale violet. दो violet.
ये वाला है क्या?
हाँ सर, ये वाला ले लो, ऊपर वाला.
ये है क्या? कोई बात नहीं. Let us take this as pale violet. Don't worry. Pale violet. And rubidium is
Red violet.
Red violet. Red violet. And cesium is
violet. Simple violet.
Okay, hope this is violet. Okay. And हमने इसके लिए reason भी समझा है. In case of sodium, potassium, rubidium, cesium, which will require higher excitation energy?
Sodium.
Because the electron is closer to the nucleus in case of sodium, hence it will be requiring higher excitation energy when compared to cesium. In case of cesium, the electron is away from the nucleus or the excitation energy that is going to be required is going to be less. And हमने एक wheel के बारे में भी पढ़ा था वो कलर के लिए.
हाँ सर, वो विबग्योर वाला.
विबग्योर वाला.
VBGYOR.
Where you have complementary colors.
सर I नहीं था ना.
इसमें I नहीं था ना.
Yeah. Thank you. So these are complementary colors. Violet का complementary color yellow है, red का green है, blue का orange है या orange का blue है, so on so forth. इसके बाद हमने कुछ डिस्कशन किया है.
हाँ, अगर वॉयलेट लाइट एब्जॉर्ब किया तो फिर एमिट होने वाला लाइट येलो होगा ऐसे.
Exactly. वो डिस्कशन होने के बाद आगे कुछ पढ़ा हमने.
With nitrogen.
हाँ, reaction with nitrogen, very important. Reaction with nitrogen. Only lithium reacts with nitrogen. Reacts with nitrogen to form nitride. To form nitride. And what is the formula of lithium nitride?
Li3n.
Li3n. And इसके लिए रीजन आपको मैं क्या समझाया?
हाँ सर, जब न्यूक्लियाई का साइज सिमिलर रहता है तब ज्यादा स्टेबिलिटी आएगा, इसलिए सिर्फ लिथियम ही रिएक्ट करेगा.
एग्जैक्टली. इसके लिए रीजन आपको ऐसा कुछ समझाया है. स्मॉलर आयन
always stabilized by smaller cation.
Always stabilized by smaller cation. Okay. And ये जो particular property है lithium का, we also associate this to ये जो nitride formation है जो भी है, this is due to its diagonal relationship with magnesium. Diagonal relationship with magnesium. मतलब magnesium जो है, magnesium can also react with nitrogen to form magnesium nitride. Okay, magnesium can react with nitrogen to form magnesium nitride. Can anyone tell me the formula of magnesium nitride?
Mg3n2.
Mg3n2. Very good. Mg3n2. यहाँ पे देखना. What is the reason for this? ये जो lithium है, if I mark some elements, lithium के नीचे you have sodium, lithium के बाजू में you have beryllium, magnesium, beryllium के बाजू में boron and aluminium, boron के बाजू में.
सर आपने गलती से वो ये गलत लिख दिया सिंबल.
या aluminium, कार्बन के बाजू में कार्बन के नीचे silicon. Okay, so in the periodic table we already know that similar family के members, same family के members जो भी है, they will be having similar properties. मतलब lithium will be having most of its properties similar to that of sodium, and beryllium will be having properties similar to that of magnesium, calcium, so on and so forth. Boron का aluminium नीचे गैलियम, इंडियम, थैलियम, इन सब के प्रॉपर्टी सिमिलर रहेंगे. एंड कार्बन के लिए कार्बन, सिलिकॉन, जर्मेनियम, ये सब के प्रॉपर्टी सिमिलर रहेंगे. बट देयर आर सम एलिमेंट्स व्हिच हैव डायगोनल रिलेशनशिप. मतलब लिथियम हैज some of its properties similar to that of magnesium. Beryllium has some of its properties similar to that of aluminium. Boron has its properties similar to that of silicon. So these are called diagonally related elements. Some of the properties of magnesium will be common to that of lithium. Some of the properties of aluminium will be common to that of beryllium, so on and so forth. This particular phenomenon is called as diagonal relationship. The reason for the diagonal relationship is because of the similar electronegativity values. If we see the electronegativity of lithium and magnesium, दोनों का almost similar है, it is close to 1. because of the similarity in electronegativity values and because of the similarity in charge density. Charge density का मतलब क्या है? What is meant by charge density? Anyone?
The number of electrons in a particular shape.
It is nothing but simply charge upon size. चार्ज अपॉन साइज का जो वैल्यू है Li पॉजिटिव का and Mg 2 पॉजिटिव because of the similarity in the charge density values. Because of the similarity in charge density values, lithium and magnesium has some of its properties, some of their properties similar, or else due to यहाँ पे you can write similar charge density. इनके साथ साथ lithium and magnesium have similar electronegativity values. Because of this particular reason, everyone, because of this particular reason, lithium जो है, it can also combine with nitrogen to form lithium nitride. Is that clear?
Yes, sir.
Okay. ठीक. Next. Reducing agent strength. Very important. Reducing agent strength. First of all, आप लोग बताओ what is meant by reducing agent?
The one which can reduce others. Means the one who gets oxidized.
One who gets
Very good. One which reduces others. Reduces others. And itself gets oxidized. And itself gets oxidized. Okay. What do I mean by reduces others or itself gets oxidized?
Loss of electrons.
Very good. Oxidized का मतलब क्या है? It will lose electrons. Loss of electrons. Reduces others मतलब
दूसरों को इलेक्ट्रॉन देगा.
The one which is getting reduced, I can say it is gaining electrons. Okay. Down the group, what do you think about the reducing agent strength? मतलब will that increase?
It will increase.
It will increase. Okay. Why do you think so?
Sir, because
as we go down the metallic property,
reactivity increases.
Reactivity increases or ionization energy decreases? Okay. So down the group, reducing agent strength. RA indicates reducing agent. Okay. Reducing agent strength increases. Matlab, lithium will be lesser than sodium, lesser than potassium, lesser than rubidium, lesser than cesium. And this is the order only in free state. Only in free state. Free state matlab I'm taking them in the solid form. I'm not taking the aqueous solution. Very important. यहाँ पे ध्यान देना. This is the order whenever I'm taking this only in free state. Whenever I take reducing agent strength in aqueous state or aqueous phase, in case of free state, can I say lithium is the weakest reducing agent?
Yes.
In aqueous state, what is lithium becomes strongest reducing agent. In fact, ये जो lithium में strongest reducing in entire S block, not only in its particular group, in entire S block. Entire S block मतलब when compared to beryllium, magnesium, calcium, वो भी consider किया तो even among them, lithium is considered to be the strongest reducing agent. The reasons for this, there are two reasons. Or else we can simply say there is one predominant reason. The reason is due to significant hydration energy. Due to significant hydration energy. So, किसी को भी hydration energy के बारे में कुछ पता है? हमने कभी डिस्कस किया है? What is meant by hydration energy?
No, sir.
Okay. सबसे पहले
Sir, hydration है ना वही ना कि the dipoles in water get attached to the ion or something.
Exactly.
हाँ सर, तो फिर ये डिस्कस किया है हमने.
Okay. देखो, सबसे पहले aqueous phase में whenever I put lithium in aqueous phase, let us see what are the individual steps that are happening while it is acting like a reducing agent. Okay. Lithium जो है, first it is in solid state. Whenever I put that in water, first immediately it converts into lithium gaseous ion or gaseous atomic state. Lithium solid converts into lithium gaseous. For this, can I say sublimation energy is utilized? Everyone. अभी आपको यहाँ करना क्या है? If I want to make lithium as a reducing agent, it has to lose electron. The process of loss of electron is called as ionization energy. Ionization energy is defined for an isolated gaseous atom. मतलब it is the amount of energy required in order to remove an electron. If I'm giving an ionization energy to this plus ionization energy, it will be converting into lithium positive gaseous plus electron. अभी ये जो भी electron बाहर आया है, that electron will be given to the another substance that is getting reduced. Okay. So whenever I'm putting lithium in water, what is the first step that is happening? Lithium solid is absorbing some energy from the water and it is converting into lithium gaseous. Once it gets converted into lithium gaseous, it is again absorbing energy from the water. It is absorbing that ionization energy and it is converting into lithium positive ion, followed by loss of electron. Once you get lithium positive gaseous, अब क्या होगा? It will be interacting with water, which is represented as aqueous, to form lithium positive aqueous. And इस process में there will be liberation of energy. That energy is called as hydration energy, He. Everyone. होगा क्या? Once you are having lithium as lithium positive, water जो है, those are nothing but dipoles. So those dipoles will be surrounding these lithium positive ions and they will be forming an interaction. I hope everyone of you know water is nothing but a dipole. ये हमने बहुत बार discuss किया. Whenever there is formation of interaction between the water and the positively charged lithium ions, what will happen? Whenever there is generation of an attractive force, what will happen to the stability of the system? What will happen to the stability?
Increases.
Increases. This particular phenomenon is called as hydration. And इस process में जो भी energy release हो रहा है, the energy is called as hydration energy. Why is the energy getting released? Because there is achievement of stability. वो जो positively charged ion जो है, as it is forming attractive forces, it will be achieving stability. Is that clear? अभी यहाँ देखना हाइड्रेशन एनर्जी का ऑर्डर एक बार देखते हैं. If I take hydration energy and if I want to compare hydration energy among Li positive, Na positive, K positive, Rb positive, and Cs positive, the order of hydration energy is lithium positive is going to liberate highest amount of hydration energy. The reason is lithium positive में charge density ज़्यादा है. Let us mark the order of charge density first. What is meant by charge density?
Charge upon mass.
Charge upon size. Charge density सबसे ज़्यादा किसके लिए है?
Lithium.
Lithium, because you are having very less amount of size and the charge is same for everything. सब में +1 charge है. If you are having more and more charge density, it is highly unstable. This is the order of charge density. Okay. So this being the order of charge density, ये जो particular lithium positive है, it is highly unstable. So in order to attain stability, what will happen is it will attract more and more dipoles towards itself, and it will be having more and more amount of hydration, and in the process it will be releasing more and more amount of energy. Okay. Is that clear? बाकी जो है, those being relatively more stable, उनका hydration उतना ज़्यादा नहीं होगा, hydration ज़्यादा नहीं होगा तो उतना energy release नहीं होगा. In case of aqueous solution, the reducing agent tendency must be measured based on these three factors combined. You should not only look at only ionization energy, but you should also look at hydration energy. Ionization energy lithium का सबसे ज़्यादा है, but hydration energy उससे भी और ज़्यादा होने की वजह से lithium is having the more tendency to immediately lose the electron, because once it loses electron, it will be forming partially charged ion. Once it forms the partially charged ion, it is going to be stabilized by the hydration energy. Is that clear? Cesium के केस में क्या हुआ? Cesium, even though its ionization energy is less, the hydration energy is also less. As a result, it is not having that much tendency to immediately convert into the partially charged species. समझ में आ रहा है? हाँ. Okay. So overall, अगर आपको order mark करना है, reducing agent strength in aqueous medium, I need to mark this order based on combined effects of ionization energy as well as hydration energy. इसमें आपको lithium positive जो है और lithium reducing agent nature, lithium जो है सबसे ज़्यादा, rubidium or cesium, they're almost similar. Then you have potassium, then you have sodium. This is the order. Lithium सबसे ज़्यादा, rubidium or cesium almost similar, then potassium, then sodium. This becomes the order. Lithium सबसे ज़्यादा किस वजह से? Because of its highest hydration energy. यहाँ पे rubidium और cesium बाद में क्यों आ रहे हैं? That may be because of their very less amount of ionization energy. इनका hydration energy कम है, but ionization energy भी कम है ना, उसकी वजह से they are able to lose the electron. Sodium और potassium जो है बीच में है. They have neither good hydration energy nor they have very less ionization energy. Is that clear?
Yes.
This is the order in aqueous solution. समझ में आया सबको? Yeah, tell me.
लेकिन लिथियम की हाइड्रेशन एनर्जी ज्यादा है तो यानी व्हाट आई मीन इसका डिफरेंस क्या होगा उसकी इस पे reducing agent की property पे strength पे?
Reducing agent strength में if I am measuring that in aqueous solution, in the aqueous solution there is one more factor which is called as hydration. Once lithium is losing electron, it knows that it will be stabilized to a greater extent because of the hydration. If there is no solvent, then ये जो particular lithium positive है वो solvation होगा ही नहीं. In that case, the only factor on which I need to determine the reducing agent strength is ionization energy. But in this case, in aqueous solution, as I am getting some hydration, the lithium is going to release that amount of hydration energy, You can also think in a different way. जो released hydration energy है, it will be utilized by the lithium atoms. It will be utilized by lithium atoms which are yet to be converted into lithium positive. यहाँ पे जो भी hydration energy release हो रहा है, that will be utilized by some other lithium gaseous atoms and the electrons will be removed. So in the process, it is giving more and more electrons. I समझ में?
Yes.
Everyone? Is that clear, everyone?
Yes.
Okay. Okay. ठीक है. Then next, there is a concept called solubility. Solubility. Suppose if I take sulfates, I'm taking sulfates of group 1, which is lithium sulfate, Li2SO4, sodium sulfate, Na2SO4, potassium sulfate, K2SO4, Rp2SO4, and CS2, cesium sulfate, CS2SO4. The question they will ask is, what happens to the solubility of these sulfates down the group? Will it increase or will it decrease? मतलब क्या है? What is how can we analyze solubility? Suppose
sir increase होगा.
वो देखेंगे. First let us understand what is meant by solubility. Okay, suppose if I am taking 1 liter of solution, 1 liter of water, उसके अंदर Li2SO4 डाल रहा हूँ. If I am able to dissolve more and more amount of Li2SO4 per unit amount of that particular solvent, unit amount मतलब in this case 1 liter solution. Suppose 100 grams of Li2SO4 मिला पा रहा हूँ, but Na2SO4 50 grams ही मिला पा रहा हूँ. In that case, I can say lithium sulfate is more soluble when compared to sodium sulfate. Is that clear? Okay. So now we need to analyze what will happen to the solubility of these sulfates down the group. So in order to analyze that, first let us analyze on what factors solubility will depend on. Everyone. पहले solubility कैसे check करना होता है वो देखते हैं. Then we will analyze what will happen to the solubility of the sulfates. Sulfates जैसे ही आपको carbonates रहेगा, bicarbonates रहेगा, halides रहेगा. You can compare solubility of different compounds. Is that clear? First, let us understand the thermodynamics involved in solubility or during solubility. Thermodynamics मतलब individual steps के बारे में analysis करेंगे. Whenever some compound is getting soluble. Thermodynamics of solubility. Let us take some ionic compound AB, solid. Whenever I put this in water, water मतलब we will be representing that as aqueous. AB solid plus aqueous. किस में convert होगा? Suppose NaCl plus aqueous. What is the equation you write?
AB A plus or B minus.
A plus or B minus. We will write that as A positive aqueous
Or B minus.
B negative aqueous. This is the equation which we write. This is the final equation. But actual में होता क्या है? Whenever I put any ionic compound in water, first what will happen is this AB solid will be acquiring an energy which is called as lattice energy. Everyone, हमने कभी lattice energy के बारे में डिस्कस किया?
हाँ सर पहले क्रिस्टल लैटिस को ब्रेक करने के लिए जो एनर्जी
क्रिस्टल लैटिस को ब्रेक करने के लिए जितना भी एनर्जी लगता है इट इज कॉल्ड एज लैटिस एनर्जी. All ionic compounds will be having some crystal lattice. Crystal lattice मतलब some regular arrangement oppositely charged ions. This is a typical ionic compound. You are having regular arrangement of oppositely charged ions. This particular arrangement is called as a lattice. Okay, suppose मान लेते this is initially AB solid. In order to break this into isolated gaseous ions, मतलब पॉजिटिव आयन एक नेगेटिव आयन जैसा ब्रेक करना है. If I am taking 1 mole of the crystal lattice, if I am supplying energy equal to lattice energy, then I will be breaking all these into isolated gaseous ions. That particular energy is called as lattice energy. Is that clear? So सबसे पहले क्या होगा, AB solid को पानी में मिलाते ही first it will be absorbing lattice energy and it will be converting into isolated gaseous ions, which are A positive gaseous plus B negative gaseous. अब क्या होगा, these A positive gaseous, they are present inside water, right? So they will start interacting with the water and they will be converting into A positive aqueous plus B negative aqueous. And in the process, they are releasing energy, right? Hence, I will be writing this as hydration energy of A positive or B negative. दोनों को combined. Hydration energy of A positive plus hydration energy of B negative. Is that clear? So, what is the overall equation? If I add these two, what will I get? AB solid, A positive gaseous cancel हो जाएगा. B negative gaseous cancel हो जाएगा. AB solid plus aqueous plus what is the energy? Lattice energy is getting absorbed, gives rise to A positive aqueous
plus B positive aqueous
plus B negative aqueous plus hydration energy of, I'm writing this as A positive, B negative. Is that clear? यहाँ पे देखना, there is one energy that is getting absorbed and there is one energy that is getting released. Whenever I put any ionic substance inside water, water के अंदर already stored energy कुछ तो रहेगा. Everyone agreed? There will be some heat energy that is present inside water. Initial क्या होगा? Suppose मान लेते हैं, let us say हमने 100 molecules of AB को पानी में डाल दिया. Okay, with the energy that is present inside water, let us say 5 molecules of AB got dissociated by taking the lattice energy. Water के अंदर जो भी energy है, that energy is utilized by the 5 molecules and they are breaking into A positive and B negative. Once they break into A positive and B negative, they will be interacting with the water molecules. If they are interacting with the water molecules, they will be releasing energy, hydration energy. If this hydration energy is greater than lattice energy, everyone understand this. अभी जो hydration energy release हुआ है, if that hydration energy is greater than lattice energy, what will happen? The remaining molecules will be absorbing this hydration energy. If they are absorbing that hydration energy, they will again break into ions. If they are breaking into ions, they will be again solvated or hydrated, which will again lead to the liberation of energy. That energy will be again utilized by the undissociated AB, so on and so forth. So eventually what is happening? The entire AB is getting dissociated. Is that clear? समझ में आया?
Yes, sir.
Okay. यहाँ पे मैं ये लिख सकता हूँ. If hydration energy is greater than lattice energy, this implies the compound which you are dissolving is soluble. मतलब वो जितना भी मैं मिलाऊंगा वो soluble होगा. जितना भी मिलाऊंगा soluble होगा. इसका मतलब क्या है? जब तक ये जो वाटर अवेलेबल रहेगा आपको सॉल्वेशन के लिए, उतना ही soluble होगा. ऐसा नहीं है ठीक है, you will be taking only one bowl of water and उसके अंदर NaCl 1 kg डाल दो, पूरा soluble होगा क्या? No, right? You need to have the water molecules sufficient so that these ions which are formed will be solvated. Whenever they are solvated, they will be releasing energy, and the same energy will be used by the undissociated AV molecules. Is that clear? Okay.
Yes, sir.
So if you have sufficient amount of water and if hydration energy is greater than lattice energy, we say the compound is soluble. Is that clear? Okay. अगर hydration energy लेस देन है लैटिस एनर्जी से, तब क्या होगा? जो भी इनिशियल वाटर के अंदर जो भी एनर्जी है वही यूज हुआ होगा, उससे थोड़ा अमाउंट ही सॉल्युबल होगा, और एल्स वो ना के बराबर ही मान सकते हैं. ओके, और एल्स वी विल से द कंपाउंड इज इनसॉल्युबल. कंपाउंड इज इनसॉल्युबल. यहाँ पे किसी को कुछ डाउट? ओके. अगर हाइड्रेशन एनर्जी ऑलमोस्ट लैटिस एनर्जी के बराबर हुआ, मतलब दोनों ऑलमोस्ट सेम है, देन वी विल से द कंपाउंड इज स्पेरिंगली सॉल्युबल. मतलब थोड़ा अमाउंट डिसॉल्व होगा, थोड़ा अमाउंट डिसॉल्व नहीं होगा, क्योंकि वो जो एनर्जी है जस्ट इक्वल है ना. सो कुछ कुछ मॉलिक्यूल्स डिसोशिएट हो जाएंगे, कुछ मॉलिक्यूल्स डिसोशिएट नहीं होंगे. सो वी से इट इज कंपाउंड इज स्पेरिंगली सॉल्युबल. मतलब there will be some soluble part, there will be insoluble part, दोनों रहेंगे. समझ में आ रहा है? Compound is sparingly soluble. Is that clear? Okay. Yes. अभी हमको यहाँ पे एनालिसिस करना है. सब क्यों पढ़ा हमने solubility के बारे में? We need to analyze what will happen to the solubility of these sulfates down the group. Will the solubility increase or decrease? वो हमको एनालाइज करना है. Everyone, if I want to analyze the solubility, see the general equation. What is happening? AB solid, whenever it is kept in water, it is converting into A positive aqueous plus B negative aqueous plus you are having some energy, hydration energy minus लैटिस एनर्जी. और लैटिस एनर्जी यहाँ पे जो भी है इससे लेके आ गया. इज दैट क्लियर एवरीवन? अगर ये वाला वैल्यू पॉजिटिव है तो आई कैन से इट विल बी सॉल्युबल, मतलब हाइड्रेशन एनर्जी ग्रेटर देन लैटिस एनर्जी हुआ. अगर ये वाला वैल्यू नेगेटिव है तो इट विल बी इनसॉल्युबल. कैन आई आल्सो से जितना ज्यादा पॉजिटिव रहेगा हाइड्रेशन एनर्जी, जितना ज्यादा रहेगा लैटिस एनर्जी से, द कंपाउंड विल बी मोर एंड मोर सॉल्युबल. मतलब कम वाटर में ही वो ज्यादा मिला सकता हूं मैं. समझ में आ रहा है? ओके. इज इट क्लियर एवरीवन?
यस सर.
यस.
ओके. ओके एवरीवन, व्हाट इज? ओके, एक बार हाइड्रेशन एनर्जी हमको किसके ऊपर डिपेंड होता है ये हमको पता है ना. हाइड्रेशन एनर्जी डिपेंड्स अपॉन चार्ज डेंसिटी. अब ये पढ़ा हमने. जितना ज्यादा चार्ज डेंसिटी है उतना ज्यादा अनस्टेबल होगा, सो उतना ज्यादा हाइड्रेशन होगा, उतना ज्यादा एनर्जी रिलीज करेगा. एनी डाउट?
No, sir.
Any doubt anyone? Hydration energy depends upon charge density. Lattice energy, can you tell me the factors on which lattice energy depends upon?
The attractive forces between ions and the size of the ions. Relative.
Lattice energy किस वजह से आया है? It is because of the attraction between the oppositely charged ions. Okay, so lattice energy will be proportional to charges. इसका चार्ज मान लेते हैं Q1, इसका चार्ज मान लेते हैं Q2. So it will be proportional to charges, and it will be inversely proportional to size, the distance between them. Okay, just like charge density, hydration energy जितना ज्यादा चार्ज होगा हाइड्रेशन एनर्जी जितना ज्यादा होगा, जितना साइज कम रहेगा हाइड्रेशन एनर्जी ज्यादा होगा. ये जो हाइड्रेशन एनर्जी है मैं भी यही लिख सकता हूँ, हाइड्रेशन एनर्जी विल बी डायरेक्टली प्रोपोर्शनल टू चार्ज एंड इनवर्सली प्रोपोर्शनल टू साइज। यहाँ पे भी जस्ट लाइक यहाँ पे एस्पेक्ट के अलावा दैट इज मार्क्ड एज साइज। एवरीवन understand this, lattice energy is also depending upon charge as well as size, and the dependence is also similar, it is inversely proportional to size। मतलब जितना ज्यादा साइज हो जाएगा लैटिस एनर्जी कम हो जाएगा, हाइड्रेशन एनर्जी भी जितना ज्यादा साइज हो जाएगा हाइड्रेशन एनर्जी कम हो जाएगा, दोनों सेम ही है ना, समझ में आ रहा है। इनके साथ
Yes.
साथ लैटिस एनर्जी और एक फैक्टर के ऊपर भी डिपेंडेंट है। हमने यहाँ पे एक स्टेटमेंट लिखा, कौन सा स्टेटमेंट? smaller anion always stabilized by smaller cation। Okay, if you are having similarity in sizes, what do you think the effectiveness of lattice going to be?
The ions will attract each other more strongly,
more effectively। यहाँ पे देखना मैंने अभी क्या कर रहा हूँ, I am taking dissimilarity in sizes, rest all other things are same। मतलब वो जो साइज ओवरऑल कैटियन का और एनियन का साइज मिला के दोनों का साइज सेम है, चार्ज भी +1 -1 ही है, बट हुआ क्या है इन साइजेस में देयर इज वेरिएशन। ओके, यहाँ पे क्या हुआ, यू हैव सिमिलैरिटी इन साइजेस, कैन आई से दिस इज मोर इफेक्टिव लैटिस? Here there is dissimilarity, can I say it will lead to ineffective lattice? मतलब दोनों में लैटिस एनर्जी इक्वल तो नहीं रहेगा, इन दिस केस द लैटिस एनर्जी विल बी लेसर व्हेन कंपेयर्ड टू दिस। एग्रीड?
Yes, sir.
Okay, ineffective lattice। अभी यहाँ पे देखना, if I'm taking Li2SO4 Na2SO4 K2SO4 Rb2SO4 CS2SO4, what do you think? ये जो सल्फेट आयन जो भी है SO4 2-, is that a smaller anion or a larger anion?
Sir, larger
because it is having several atoms, 5 atoms है, SO2- जो है it is considered as a larger anion। okay, so सब में SO4 2- ही है, नेगेटिव, यहाँ पे भी नेगेटिव। I am taking the size of the anion to be similar। okay, as anion is common, I may not compare the hydration energy of the anion। is that clear? okay, cation में you are having Li positive, initially वो smaller है, Na positive थोड़ा बड़ा है, K positive और थोड़ा बड़ा है, Rb positive और बड़ा है, CS positive और बढ़ गया है। Agreed? Down the group, what is happening to the packing?
getting better।
Effective होता जा रहा है।
हाँ।
Down the group, packing is becoming more and more effective। What is the reason for that? Because of achievement of similarity in sizes. Can I say that?
Yes, sir.
Down the group, सबसे पहले, if I want to compare the solubility, I need to compare hydration energy and lattice energy. Down the group, what is happening to the hydration energy? Down the group, what is happening to hydration energy?
Decrease.
Decrease हो रहे. देखो एनियन सब में कॉमन है, हाइड्रेशन एनर्जी ऑफ एनियन के बारे में भूल जाओ. डाउन द ग्रुप साइज ऑफ द कैटन इज इंक्रीजिंग. इट डिपेंड्स ऑन चार्ज डेंसिटी ना. चार्ज तो सब में सेम है, साइज क्या होता जा रहा है? बढ़ता जा रहा है. साइज बढ़ता गया तो हाइड्रेशन क्या होगा? घटता जाएगा.
Decrease.
If hydration decreases, hydration energy also decreases. Agreed?
Yes.
So down the group, if I am going from Li to SO4 to CH to SO4, hydration energy जो है, it is getting decreased. Hydration energy decreases. Please tell me what is happening to lattice energy? Increase या decrease? इतना ही बताना.
Increase.
Lattice energy, everyone understand this. Lattice energy depends upon charge, size. उसके साथ साथ और एक फैक्टर है पैकिंग. साइज बढ़ता जा रहा है ना. If size increases, what will happen to the lattice energy? It will definitely decrease. Okay. So यहाँ पे everyone, very very important, lattice energy भी घट रहा है. Okay. Everyone understand this. Last point. Conclusion. हमको हाइड्रेशन एनर्जी माइनस लैटिस एनर्जी का एनालिसिस करना है. हाइड्रेशन एनर्जी भी घट रहे, लैटिस एनर्जी भी घट रहे. बट व्हाट विल हैपन इज बिकॉज ऑफ अचीवमेंट ऑफ पैकिंग, ये जो लैटिस एनर्जी जो भी घट रहे, दैट डिक्रीज वोंट बी वेरी शार्प. इट विल बी डिक्रीजिंग स्लोली. आया समझ में? There is one factor that is contributing to a better lattice. Because of that factor, even though the lattice energy is decreasing, why is the lattice energy decreasing? Because of increasing size. Even though the lattice energy is decreasing, the decrease won't be faster. आ रहे समझ में?
Yes.
Okay. So यहाँ पे what I can write is hydration energy is decreasing relatively at a faster rate, but lattice energy is decreasing relatively at a slower rate. छोटा एरो उसको बड़ा एरो शो किया. समझ में आ रहे?
सर.
हाँ, टेल मी.
सर यानी हम पैकिंग को, यानी पैकिंग ऑफ आयंस को एक लैटिस में सेकेंडरी रीजन मानते हैं. रीजन मान रहा हूँ, बिकॉज मेन कंट्रीब्यूटिंग रीजंस तो यही है, चार्ज और उनके साइज है. पैकिंग के वजह से जो भी लैटिस बेटर होता जा रहा है, उसके वजह से लैटिस एनर्जी पे जो डिक्रीज है ज्यादा नहीं रहेगा, थोड़ा कम रहेगा. मैं ऐसा बोल रहा हूँ. आया समझ में? यस.
एवरीवन, लेट अस टेक सम एग्जांपल्स. अगर आपको समझ में और बेटर आने के लिए, लेट अस टेक इनिशियली द हाइड्रेशन एनर्जी इज 20 and let us take the lattice energy is 10. Okay. Hydration energy down the group is decreasing. Let us take 2 units से घटता जा रहा है. 18 हुआ, 18 से 16 हुआ, 14 हुआ, 12 हुआ. Lattice energy थोड़ा धीरे धीरे से घटने की वजह से let us take the decrease by only 1. ये 9 हुआ, 9 से 8 हुआ, 7 हुआ, 6 हुआ. Okay. Hydration energy is decreasing at a faster rate, but lattice energy is decreasing at a slower rate. So hydration energy minus lattice energy यहाँ पे कितना है? 10. यहाँ पे कितना है? 9. यहाँ पे कितना है? 8. यहाँ पे 7. यहाँ पे 6. So what is happening to hydration energy minus lattice energy? It is decreasing.
Yes.
So what should happen to solubility? What should happen to solubility? जितना ज्यादा
Decrease.
डिक्रीज. जितना ज्यादा हाइड्रेशन एनर्जी माइनस लैटिस एनर्जी रहेगा, उतना बेटर रहेगा मेरे लिए. आ रहे समझ में?
हाँ.
यहाँ पे हुआ क्या है? What is the reason? As this is a larger anion, down the group, as this is a larger anion, down the group, there is achievement of packing efficiency. because of which the lattice energy is decreasing at a slower rate. Okay, so यहाँ पे मैं ये लिख सकता हूँ, lattice energy decreases slower when compared to hydration energy. I can take one more example. इसको साइड में रखता हूँ for your reference. Let us take one more example. Let us take fluorides. Lithium fluoride, sodium fluoride, potassium fluoride, rubidium fluoride, cesium fluoride. Can I consider ये जो fluoride है a smaller anion?
हाँ.
Can I?
यस सर. अभी तो हाइड्रेशन एनर्जी और लैटिस एनर्जी दोनों अप्रोक्सीमेटली सेम रेट से डिक्रीज होंगे ना, क्योंकि पैकिंग भी इसे नहीं सपोर्ट करेगा.
देखते हैं अभी क्या हो रहा है डाउन द ग्रुप. व्हाट इज हैपनिंग टू द साइज ऑफ द कैटियन? वो बढ़ता जा रहा है. वो बढ़ने की वजह से डाउन द ग्रुप आई कैन डेफिनेटली से हाइड्रेशन एनर्जी इज गोइंग टू डिक्रीज. ये तो होगा ही है. लैटिस एनर्जी भी डिक्रीज ही होगा. बट इन दिस केस ये जो पैकिंग है वो बिगड़ता जा रहा है ना. अगर बिगड़ता गया तो कैन आई से लैटिस एनर्जी विल डिक्रीज एट अ फास्टर रेट. Decreases faster when compared to hydration energy. Can I say that?
Yeah.
So इस केस में if lattice energy is decreasing faster, what should happen to solubility? Increases.
हाँ. यस.
समझ में आ रहा है? इसके केस में क्या solubility decreases. आ रहा है समझ में?
सर उल्टा उसमें इंक्रीज होना चाहिए था ना.
इट इज डिक्रीज लोअर रेट ना. मुझे हाइड्रेशन एनर्जी माइनस ये इसके लिए हुआ. दिस इज फॉर दिस. इसके लिए अलग से आपको मार्क करना चाहिए. अगर ये है एग्जांपल में यू कैन टेक यहाँ पे 20 अगेन. यहाँ पे अभी क्या करना है? दिस इज डिक्रीजिंग एट ए स्लोअर रेट. सो ये 19 कर लेना, 18, 17, 16. ये 10 से दो दो घटा दो. 8, 6, 4, 2. सो इन दोनों के बीच में डिफरेंस कितना है?
10, 11, 12, 13.
10, 11, 12 ऐसे बढ़ रहा है.
हाँ, तो बढ़ता जा रहा है ना.
हाँ.
सो सॉल्युबिलिटी इंक्रीज होगा. जितना ज्यादा हाइड्रेशन है लैटिस एनर्जी से सॉल्युबिलिटी बढ़ेगा. आया समझ में?
सर लेकिन पहले पैकिंग और इफेक्टिव होती है सोडियम तक, क्योंकि सोडियम पॉजिटिव और फ्लोरीन नेगेटिव का यानी फ्लोराइड आयन का साइज सेम होगा ना ऑलमोस्ट.
ये साइज अभी कंपेयर रिलेटिवली देखेंगे. अभी फ्लोराइड का Li पॉजिटिव का साइज सिमिलर रहेगा या Na पॉजिटिव F माइनस का साइज सिमिलर रहेगा. दैट वी डोंट नो अनलेस एंड अंटिल वी हैव द वैल्यूज. ओके, सो इट डिपेंड्स अपॉन लॉट ऑफ फैक्टर्स. सो सारा हम बस रिलेटिवली डाउन द ग्रुप पैकिंग थोड़ा बिगड़ता जा रहे हैं, इस वजह से सॉल्युबिलिटी बढ़ता जाएगा. ओवरऑल एक जनरल ट्रेंड लिखा है. आया समझ में? Okay, I hope this is clear. If you got this order, let us take one more example. ये हो गया fluorides. Let us take hydroxides. Let us take the order for hydroxides. LiOH, NaOH, KOH, RbOH, CSOH. आपको इनमें कंपैरिजन के लिए ओवरऑल आपको लगेगा क्या? You need to know the size of the ion. Here I am considering OH minus. नहीं तो आपको दे रहा हूँ OH minus is considered as smaller anion.
सर तो फिर जैसे फ्लोरीन में हुआ वैसे ही होगा, फ्लोराइड्स में ऐसे हुआ वैसे.
Exactly. So down the group, what will happen?
Solubility will increase.
Lattice energy
decreases rapidly.
Faster when compared to hydration energy. This implies solubility increases. इसी पर्टिकुलर रीजन से हम ये भी बोलते हैं CSOH is a stronger base. Okay, is that clear?
हाँ.
ओके, एक बार वापस यहाँ पे जो भी लिखा है प्लीज गो थ्रू दिस. इफ यू हैव एनी डाउट आस्क मी. If you have any doubt, ask me. So हमको overall we can classify the ions. ये जो anions जो भी रहेंगे we can classify them into two sets, large as well as small. आपको इतना ही याद रखना है, small के केस में we have only two examples, F minus, OH minus. Rest all other are considered as large. मतलब sulfate, SO4 2 minus, nitrate, NO3 minus, in fact Cl minus, Br minus, these are also considered as large. Okay, F minus, OH minus, only these two are considered as small. Is that clear? Okay, if I take आपको सिमिलरली नाइट्रेट्स का ले रहा हूं. Tell me the order of solubility. Lithium nitrate, sodium nitrate,
Sir, solubility will decrease.
Solubility will decrease. मतलब LiNO3 greater than, NiNO3 greater than, KNO3 greater than, RbNO3 greater than, CSNO3. यही है ना?
हाँ हाँ.
Any doubt, anyone?
No, sir.
Okay. Okay. Then we have another concept called thermal stability. Thermal stability. What is meant by thermal stability? It is nothing but stability towards heat. Stability towards heat. It is different from melting and boiling. Everyone, thermal stability has nothing to do with melting and boiling. Stability towards heat matlab, suppose if I have CaCO3, which is called as calcium carbonate, उसको हीट किया तो क्या होता है, इसका डिकम्पोजिशन होके It converts into different compound, na? CaO and CO2. If the heat that is going to be required for this particular reaction, अगर वो ज़्यादा है तो we say it is more thermally stable. अगर वो कम है तो कम thermally stable. So one more standard set of questions they ask is based on thermal stability. Okay. आपको Fazan's rules मैंने पढ़ाया है to compare the covalent character. Remember?
सर नाम याद आ रहा लेकिन यानी रूल्स याद नहीं आ रहे.
नाम याद आ रहा है बट रूल्स याद नहीं आ रहे. ठीक है. अभी ये जो थर्मल स्टेबिलिटी जो है, it can be compared based on two factors. One is based on lattice energy for simple anions. Simple anions मतलब the one which is made up of only one atom. One atom मतलब like H minus, F minus, Cl minus, etc. And the other is based on covalent character. Thermal stability based on covalent character for complex anions. Complex anions मतलब one which is made up of more than one atom. CO3 2 minus, OH minus is also considered as complex anion. Sulfate, SO4 2 minus, etc. Okay. आपको क्या लग रहा है? लैटिस एनर्जी ज्यादा है तो थर्मल स्टेबिलिटी क्या रहना चाहिए?
थर्मल स्टेबिलिटी ज्यादा होना चाहिए सर.
थर्मल स्टेबिलिटी ज्यादा होना चाहिए. More the lattice energy, more should be the thermal stability. So if I take these compounds, the hydrides ले रहा हूं मैं. Lithium hydride, sodium hydride, potassium hydride, rubidium hydride, and cesium hydride. Tell me the order of lattice energy. Answer fast.
सर लैटिस एनर्जी रैपिडली डिक्रीज होगा.
डिक्रीज होगा रैपिडली और ठीक है डिक्रीज होगा. अभी के लिए इतना ही बात करते हैं. सॉल्युबिलिटी के टाइम में और रैपिडली ये सब बात करेंगे. फॉर नाउ द लैटिस एनर्जी इज गोइंग टू डिक्रीज एज द साइज ऑफ द कैटन इज इंक्रीजिंग. एग्रीड? So if this is the order of lattice energy, this will exactly be the order as same for thermal stability. Understood?
Yes, sir.
If I give you lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. Tell me the order of thermal stability.
सर ऊपर जैसा सेम
ही रहेगा.
हाँ.
Okay. But if I give you complex anion, एक क्वेश्चन बताया था ना ऊपर, Li2CO3 Na2CO3 potassium carbonate K2CO3 Rb2CO3 CS2CO3. या यहाँ पे ऐसा याद रखना, लोअर और sorry, a smaller cation induces more covalent character. Okay, everyone please put your video on. A smaller cation induces more covalent character. Greater the covalent character. CC indicates covalent character. Greater the covalent character. Covalent compounds in general thermally less stable रहेंगे, ionic compounds thermally ज़्यादा stable रहेंगे. So covalent से ज़्यादा आ गया तो greater the covalent character, less is thermal stability. Okay.
सर मतलब exactly opposite होगा इधर.
Exactly opposite होगा. So thermal stability में यहाँ पे lithium जो being smaller, covalent character का order क्या रहेगा? Suppose if I want to mark covalent character in this, ये रहेगा. What will be the order of thermal stability? उल्टा.
हाँ उल्टा.
So अगर आपको complex anions आ गया, sulfates, similar will be the order for the sulfates, similar will be the order for nitrates. Okay, complex anions के केस में thermal stability कैसे compare करना है based on covalent character. You will understand how to compare covalent character और उनके details हम next class में पढ़ेंगे. covalent character कैसे समझना है and ऐसा क्यों हो रहा है, covalent character की वजह से thermal stability उल्टा क्यों हो रहा है. You will understand that. पर now इतना याद रखो, lattice energy ज़्यादा है तो thermal stability ज़्यादा होगा. That we will be seeing only for simple anion space. If we are having complex anions, इसमें lattice energy comparison किया तो आप लोग, this is having the greater lattice energy, but you should not compare based on lattice energy in this case. You will need to compare based on covalent character. More the covalent character, less will be the thermal stability. Is that clear?
Yes, sir.
Okay. So in today's lecture, हमने दो important चीजों के बारे में पढ़ा. One is solubility and the other is thermal stability. Both the things are very, very important. You will be asked direct questions in your entrance exams. Thermal stability के order, solubility के order. Solubility के case में you need to break that as large anion and small anion. Thermal stability के case में you need to break that as simple anion and a complex anion. Complex anion मतलब more than one atom, simple anion मतलब एक atom. Is that clear?
Yes, sir.
I will post these notes. Please go through these notes. We will analyze some other important points in our next lecture. Okay.